For question 16.14, we're asked for the pH of a buffer that's prepared by mixing 30 milliliters of 1 molar hydrofluoric acid and 20 milliliters of 2.5 molar potassium fluoride, given that the Ka of hydrofluoric acid is 7.2 times 10 to the minus 4. Eventually, we're going to need the Henderson-Hasselbalch equation for this calculation, but first we need to find what is the concentration of our acid and the concentration of our conjugate base. Our acid is HF, and our conjugate base is the potassium fluoride. We mix both of those together, and we need to find our new concentration of each of those. So I have 30 milliliters of 1 molar hydrofluoric acid. I mix that with 20 milliliters of 2.5 molar potassium fluoride. Here's my acid, and here's my base. But the important thing is I've mixed these two solutions together. I've added these solutions together, so my new volume of this solution is 50 milliliters. I need to find my new concentration of HF and my new concentration of potassium fluoride at this new volume of 50 milliliters. This requires an equation we covered in Chem 106. M1V1 equals M2V2. Basically, the molarity of my first solution times the volume of my first solution equals the molarity of my second solution times the volume of that second solution. So for the hydrofluoric acid, initially I have 1 molar solution and I have 30 milliliters of that solution. I want to know what the concentration of that solution is when I dilute that solution to 50 milliliters. Do the same calculation for the potassium fluoride, except for I have a 2.5 molar solution and I take 20 milliliters of that solution. What is my new concentration of that solution when I dilute it to 50 milliliters? So for the hydrofluoric acid, my new concentration is 0.6 molar. And for the potassium fluoride, my new concentration is 1 molar. Now I can use the Henderson-Hasselbalch equation, which is pH equals the negative log of my Ka plus the log of the concentration of my base over the concentration of my acid. So for the Henderson-Hasselbalch equation, the pH will equal the negative log of 7.2 times 10 to the negative 4 plus the log of my base, which is 1 molar, divided by concentration of my acid, which is 0.6 molar. So the pH of this solution would equal 3.143 plus the log of base over acid, so 1 over 0.6. So when I add those two together, I get a final pH of approximately 3.36. So the step that makes this calculation hard is exactly that. Going back to Chem 106, when we talked about concentration, we talked about dilution, and M1V1 equals M2V2. If you're ever going to work in a lab, a biology lab or a biochem lab, making any buffers or any solutions, that will be a very handy calculation to know, because quite often you're going to take a solution of a known concentration and dilute that to a solution of a concentration that you'd like to work with. So a less concentrated solution under a new volume. So that's what we did here. We mixed these two solutions together, 30 milliliters of hydrofluoric acid with 20 milliliters of potassium fluoride to get a 50 milliliter solution. And because my volume changed, that means my concentration will also change. So we had to find our new concentration for both the acid and the conjugate base before we could find the pH of this solution.